Okay, another thing I wanted to kind of talk about was how do we decide whether or not something's easier to graph or use substitution? Well, honestly, I would graph both of these because I like graphing. Maybe you don't really care for graphing that much. This one honestly would be easiest to graph because it has a fraction. And we want to keep it as a fraction. And remember, this is rise. We have our rise over run. So that's easiest to graph because you already have rise and run, and you also know where your y-intercept is. You know where to begin. So this one here, you can also graph. It has rise, and you can do over 1 to as your run. Another strategy you could do is substitution. So I'm going to show you how to use substitution, and I'll use a different example to show. The reason substitution could work for this is because you have some nice numbers that are not fractions, and you also have y isolated. You see how y is equal to some expression here? So we're going to go ahead and use that. Example of one that I could possibly just graph because I know they're in y equals mx plus b format. But I also know I could substitute because see how y is alone on one side of the equation? So I'll show you the substitution method because on your test you're going to need to be able to substitute as well. So let's just look at what they're saying y is equal to. Well, y is equal to 3x minus 10. And that means anywhere I see y, I can actually not write y. I can write 3x minus 10. So I see a y right here. Do you see that? So since y is 3x minus 10, I could just substitute it in for y. So that would look like this. 3x minus 10 equals 2x minus 5. And now I'm not really dealing with any y variable now because this is y and this is y. They're both equal to y. So since we have no other variable, we're going to go ahead and just solve for x, which is kind of fun. We just box and we circle, and we box and we circle, and we have to get all our boxes on one side and all our circles on the other. And I wrote really big. I'm going to try to write a little smaller. Okay, so I'm going to move my smallest box. This is a positive 2. I need a negative 2x. And whatever I do to one side, we do to the other. Now I'm left with just x. And it's going to be, I'm going to bring minus 10 down, and I'm going to bring negative 5 down. And this right here, if you look, it's 0. So let's see, let's rebox and recircle. I have 1x there, and then I have a negative 10, and oh, I'm so close. I need to get these two separated. I don't want a box and a circle together. This constant term needs to be out of there. So I am going to, I'm hoping you're thinking it, add 10. And if I add 10, that is now 0. And whatever I do to one side, I'll do to the other. So add 10. Okay. Now, some people struggle with negatives. If you spent $5 and then, or maybe you're negative $5 in your bank account and you deposit 10, put $10 into your bank, then you only have $5 in there because you owed the bank 5. So, or you can check on your calculator. And so what does x equal? X equals 5. Okay, great. Now all I need to do is solve for y. And that's not too bad. I'm just going to take one of these original equations and I'm going to put in, let's actually, you know what I'm going to do? I'm going to take the draw tool and I'm going to draw over one of the variables. So x is 5, so it doesn't matter what I use. So I'm going to draw over this x. I'm erasing x because, well, I know what x is. X is 5, so I'm putting 5 instead. Okay, 2 times 5 is 10. 10 minus 5 is whatever y is. 10 minus 5 is just 5. So y equals 5. Y equals 5. If that looked a little crazy to you, let's go ahead and what I'll do is you can stay and I'll erase most of this except for what we know. Okay? And we know that x is 5. Okay? So now I'm going to just show you what I did. Oops, I need to erase it. All right. I took this equation and I just said to myself, well, x is 5. Therefore, I'm going to put 5 in for x. So that would look like this. Y is equal to 2 times 5. Y is equal to 2 times 5 minus 5. All right, well, 2 times 5 is 10. and you bring this down, minus 5. Y is equal to 10 minus 5. So therefore, y is equal to, well, 10 minus 5 is 5. So that is my y value. So now I have x and y, and that means that the point of intersection where the lines are crossing on the graph would be at 5 and 5. So 5, comma 5. There's my ordered pair, my x and my y.